Please welcome our next speaker, Micha Vuk, a Dynamics 365 Finance and Operations software architect. Today, he will be presenting what is Azure Key Vault and how to use it in D365FO. Please stick around after Micha's session for a live Q&A.
Welcome to this Dynamics Con session. Today, I'm going to present how you can securely store your application credentials and certificates in Azure Key Vault and use them from Dynamics 365 for finance and operations. I'm Micha Vuk, and I'm a software architect at Docentric. We're specialized in providing technology to enhance document report customization and document output management in Dynamics 365 for finance and operations. It covers also electronically signed business documents like e-invoices, and that was the motivation for today's session. We also like the idea of Dynamic Con superhero, so I'm dressed like this today. If you will have any questions during the presentation, just feel free to post them in the chat window and I will answer them at the end of the session. In the first part of the session, I will explain what Azure Key Vault is and how to use it. In the second part, I will present various use cases and how to use it from F&O. In both parts, we'll try to be practical and spend most of our time for the demos. So, what is Azure Key Vault? It's a secure storage for your secrets, where secret can be anything that gives you some access or proves your identity, like passwords, connection string, API keys that are actually just application passwords, then cryptographic keys and certificate. It offers REST API, and on the top of it, you can also use command line interface, PowerShell, .NET SDK, or something else. The API contains management operations like create, list, get, delete, backup, restore, and cryptographic operations like encrypt, decrypt, sign, wrap key, and so on. And what is most important, it offers also advanced security mechanisms that you can use to make the Key Vault really secure. It's still not easy, and you have to close all the doors by yourself, but you can do it. So the basic idea is to keep your secrets on a safe place, or multiple safe places. The security settings are set per Key Vault. If you want to treat your secrets differently in terms of security, you put them in a different Key Vaults. But avoid creating more Key Vaults than is necessary from a security aspect. Key Vaults allow fine-grained permissions, but then it's up to the administrator to ensure that everyone has just the minimally required privileges. The developers should not have any access to production Key Vaults. The administrator should have the management access, but should not use the secrets. Users and applications that actually use the secrets should have granted just the cryptographic operations that they need. Auditors should have just audit permissions, and of course, all actions are logged. There's a lot of best practice material on the internet how to properly segregate the duties. We won't go into the details here. Permissions are grouped in so-called data plane that covers all cryptographic operations on keys and certificates, and management plane that covers all other operations. The administrators can manage all permissions, but they shouldn't have the data plane permissions enabled. If you want that your most important cryptographic keys are created on a special device and they never leave it, they should be generated in a so-called hardware security module that is supported in the premium tier. You can use a shared hardware security module or one reserved just for you. That gives you the maximum security level and compliancy with most demanding computer security standards. Even the best permission system does not solve the problem if the attacker steals the user credentials. To cope with that, we have a firewall and networking rules, where you can precisely specify from where the user can access your Key Vault data plane. But if the attacker still breaks into the system, Azure Defender is there for advanced threat protection. So to summarize, the management plane access is meant for administrators and is secured with a strong multi-factor authentication, while the data plane is typically used by applications like F&O and is secured with minimal permissions and network security. Now, let's see what secrets are stored in a key vault. The term secret is used here in an ambiguous way because it is used on one side for all the objects stored in a key vault, and on the other side, it is used for simple text credentials. So, the objects stored in a key vault consists of text secrets, keys, and certificates. The idea behind storing text secrets is to use the key vault as a cloud password manager. You store your passwords in a secure storage, and you can access them from everywhere and copy-paste without showing them. The idea behind keys is to have cryptographic keys for asymmetric cryptography, so actually private public key pairs that you use without certificates. It can be used for secure communication or similar scenarios, where the other party knows the public key and trusts this key in advance. Digital certificates are most important object in a key vault. They can be used for digital signatures and secure communication without pre-established trust. Every certificate has a limited validity period, and Key Vault also takes care of automatic renewal and expiry notification. So what is digital certificate? Digital certificate, or also known as a public key certificate, is an electronic document proving the identity of a key owner. It contains various data about the owner, public key digest, intended key usage, and a signature of certificate authority. The key owner, also called certificate subject, can be a person, a company, a website, or something else. But whatever it is, its identity has to be verifiable, and the trusted certificate agency has to verify it before signing the certificate. Because minimum required key lengths grow over time, every certificate has a limited validity period. The main purpose of a certificate is to provide trust in the identity of the certificate owner in advance, so before the parties actually know each other. Therefore, the value of certificate is based on the level of trust of a certificate agency. The more trusted the certificate agency is, the more widely accepted are their certificates, and the more they will charge you to issue the certificate. For internal use, you can also set up an internal certificate agency and issue the certificates for free. But those certificates will only be trusted on internal devices that trust the certificate agency. You can even avoid the certificate agency and sign the certificate with its own key. That is called a self-signed certificate. Such certificates are used just for testing, as nobody trusts them in advance. There's a lot to explain about the structure of certificates, how to trust them, and how to revoke them if the key was stolen. We won't dig into these details here. Just keep in mind that other parties will automatically trust the certificate if it was not revoked, and if they trust its issuer. That recursively applies to the certificate of the issuing agency, and so up to the trusted root. Certificates and their keys can be used for different purposes. Most important are digital signature, client authentication, and secure communication, like SSL and HTTPS protocol. Now it's time for the first demo. So we are logged into the Azure portal, where we have just created a resource group. And let's create our first key vault. We have to give a name to a key vault, and this name has to be globally unique. Then we choose a region, and we choose a pricing tier. We can choose between standard and premium pricing tier. Premium pricing tier includes support for hardware security models. So the keys that never leave this hardware security model, and we choose that one for the demonstration. We can enable soft delete, so it means whatever it will be deleted, keys, certificates, secrets, it will not really be deleted, but it will be just put in the recycle bin. And it will stay there for the end of the retention period. And the retention period is up to 19 days, and we have set 19 days. And if that's enabled, even if the whole key vault will be deleted, it will still be in the recycle bin, and you will be able to recover it in the retention period. For the objects that are in the retention period, you can enable purge protection. It means this object cannot be deleted at all during the retention period. If it's disabled, you can manually purge them to delete them completely. Okay, then let's go to the next step. That tab defines the permissions for the owner of a key vault. Here we see the key permissions. These are the permissions for the management plane, and these are the permissions for the data plane. So the administrator should not have the permissions for the data plane enabled. These are other permissions for secrets and for certificates. Okay, if we continue with networking, we have a chance to allow that Key Vault is accessed from the whole internet, or to limit it to a specific virtual networks, or to private endpoints that are connected with a private link. Okay, let's go to review and click create. We have the resource created, and here's our Key Vault. That's the name of a Key Vault. That's the URL that's globally unique and contains the name. And this is the permissions tab. And this is the networking tab. And here are the keys, secrets, and certificates that are the objects inside of a Key Vault. Let's start with secrets, with text secrets. Let's create a simple text secret. We can put it in a password or connection key or whatever. We can set an activation date, an expiration date, and enable or disable it. We have just created our first secret. If we click in, we could have multiple versions. And let's create another version. A new password, version 2 for the description, and that's it. Now we have two versions, both are enabled, and if you would access this secret from an external application, by default we would get a current version, but we could also explicitly request a specific version. Okay, now let's go for the keys. We'll create one key. We can choose a key type, actually the algorithm, and if we use a premium tier, we can also choose between a hardware security model-backed keys using the RSA or elliptic curve algorithm. The key lengths that we can select, the minimal key lengths is the minimum requirement for a secure key usage nowadays, and the longer keys are give us better protection for the security in the future years. We can again set the activation, expiration, enabled, and that's it. Okay, that were the keys. Now let's go to the certificates that are actually the most important for us. So when we are creating a certificate, we have several options like we have described it a few slides ago. So the simplest one is self-signed certificate. And let's start with this. Here we select to have a self-signed certificate. Here we should describe who we are, actually, what is the subject of certificates. Then we select the validity and the automatic renewal of certificate just before the expiration, and the parameters of a key. We already know the basic key parameters. Here we can select whether we want that the key is exportable or not. If we select a non-exportable key, we can also select the HSM options if we use a premium tier. And under key usages, we can select the default key usages give us digital signature and communication. We can also add other purposes if we need them. Now we have initiated the creation of a new key and new certificate. It takes some time, and in the meantime, this certificate is still disabled. So during that time, let's see what other options we have for certificate generation. We can use an integrated certificate agency that currently just DigiCert and Global Signer is supported. That gives us option that's pretty much similar like self-signed, but then you give a real trusted certificate. And that, of course, we need an account of these agencies, and we have to pay that. If we use some other certificate agency beside these two listed, not directly integrated with Key Vault, we have to use the following procedure. We select none. We fill out all the data for the certificate, and for the key, let's say it will be a non-exportable key, and let's RSA. And now we actually create just the certificate signing request. It contains all the data that we specified for the certificate and the data about the key, because the key was already generated. Then we download the certificate signing request, that's a special file. We upload it to our certificate agency that signs this certificate request and give us another file that proves the data about the signed certificate. Then we upload this file here to merge, and the Key Vault merges both two together, and so we get a real certificate at the end. In the meantime, our self-signed certificate was already created. The other option is that we can import the certificate if we have a certificate with the private key generated somewhere else, and we just move it from some other system to our Key Vault. Let's select the file extension. For that purpose is PFX. Let's select that certificate. I have to type the password. Okay, it works. We have successfully imported the certificate. Okay, that was the introduction. The rest will be demonstrated on practical use cases. Now, when we know how to store the secrets in a Key Vault and how to make it secure, let's see how to access and use it. We could use .NET SDK, PowerShell, or some file signing tool for demonstration. Today we won't go into it, but we'll focus on what can we use from FNO. First, why should we use the Key Vault in FNO? One reason is to avoid storing secrets in your FNO database. Secrets in FNO database can be encrypted, but it's still possible to read them. And number of people that actually have access and can do it is not negligible. And they can do it alone and without getting noticed. If we put the secrets in the Key Vault, FO will still need some credentials in the database to access the Key Vault. But we can bound the access also on a network level, so no one else will be able to use these credentials from somewhere else. If something suspicious happens, we can just replace the access credentials without the fear that delicate keys from the Key Vault has been stolen. The second reason is that secrets in a Key Vault are much better managed. You have versioning, audit logs, and automatic renewal of keys and certificates. So altogether, we have a good motivation to keep our delicate secrets in a Key Vault and use it from FNO. In the second demo, we will first show how to access Key Vault from FNO to use a simple text secret. For the use case, we will take a creation of event grid endpoint from my last Dynamics concession. But that is actually not important. The important detail here is that event grid access key is not entered in an FNO, but it's stored in a Key Vault. Then we will take a look how we can leverage Key Vault certificates to sign the XML e-invoice, and at the end, also to sign the PDF documents. The latter is not supported by the standard, so we will use a third-party solution. Okay, so first we have to create an access to the Key Vault. And to grant an access, we need to create an application in our Azure Active Directory. Here we create a new application, or actually register it. Okay. And this is the application ID, and we will store it for further use. Then we also need to create a password, that's called the client secret, to authenticate the name of this application. We see this password only once, so we'll store it as well. Good. Then we go to the Key Vault and grant some permissions to this application. We can select among different users or applications And as we have an application ID, we just paste it here and select it. Then we would like to grant the minimal required permissions for our use cases. We will select the signature permission and the list permission for the keys, for the secrets to just get, so actually read the secret, and for the certificate the same. Okay, and don't forget to click save. Oh, I deleted something before. Okay, that's fine. Now let's go to the FNO and see what was our idea for the use case. So here in the business events, we can create various endpoints, and event grid is just one type of an endpoint. I've just created before an event grid topic, and we will use it for the demo. That's the name of an event grid topic. This is the URL. And to access the event grid topic, you need an access key. And I would expect to enter the access key here, but that's not the case. Instead of it, it asks me to provide the Key Vault parameters, and apparently it expects that the access key will be stored in a Key Vault as a secret. Okay, so let's store this access key in a Key Vault as a secret. Okay, and now we'll paste the parameters in. That was the name of a key vault of the secret. That's the Key Vault URL. And this is the application ID that we use to access Key Vault. And this is the application password. Now hold the fingers crossed. And if you have filled out everything correctly, the endpoint will be created. Good, we did it. Okay, that was a quite specific use case. Now let's see a more generic support for using Key Vault in FNO. So we'll start with the Key Vault parameters form. So here we can create a connection to our Key Vault. We again need the Key Vault URL. That's global unique. And we'll use the same application and its password for access. Okay. Then we will register the secrets that already exist in a Key Vault also here. It sounds a little bit like double work, but that's the way it is. So we'll select my secret. And let's type just vault. And when we try to save, the warning explains us what's the syntax that's actually expected. Demo and my secret. Okay. And now we can validate it. Oh, sorry, my bad. It's not a certificate, it's a manual secret, so a text secret. Okay, that works. Okay, now let's register some certificates. Okay, and validate it as well. Okay, and the third one. Don't care about these warnings, they are expected during the... Okay. Now, if I click a validate now, there is a bug in version 10.0.16 and earlier probably also, that actually when you click validate, it takes just the first validated certificate from cache, so it would not really validate it. We should reload the page. It should work. We won't troubleshoot now. Let's go on with the use case. That were the Key Vault's parameters. So let's see where in the application we can use them. That's the Key Vault certificate helper, and if we find the references, here are different places in the application where the certificates are used. It's used in some localization features, some Brazilian, Mexican one, mostly for the tax reports. Here's for the Netherlands, Germany, and not too many places. But here you can also notice that there is a table XML certificate that references these Key Vault certificates. Okay, now let's go to this table. It's called electronic signature certificates, and let's add the certificate. Okay, we will select our first certificate, and we can select to link it to the company or to the user. We'll link it to the current user and activate it, and we'll bound the second certificate to the company. Okay. In order to really use Key Vault certificates, we should enable one flag in the system parameters. That's called Use Advanced Certificate Store. So that activates Key Vault's the usage of Key Vault certificates. Otherwise, the legacy Windows Store certificates would be used by default. Okay. Now let's see where are these XML certificates used. So actually, there's just one place where it is used in the standard application, and this is a part of Italian localization, sending XML e-invoices. Okay, this is the place. Okay, that's how it looks. We will select some of the already posted invoices. And we'll choose one. Then we'll create an XML from the invoice data. Okay, that's it. And sign it. Okay, we can sign it with that certificate. And now we will send it. It's a pretty complicated setup how to generate this XML and how to send it further. So for this demo, we just download it, and then we should upload it to Tax Authority. Okay. So in this XML, there's also a signature part that explains what was signed with which certificate, and this is the signature itself. Okay. So that was the electronic invoice as signed XML that is well suited for tax authorities and sometimes also for the business-to-business. For sending invoices and other electronic documents to the end customer, it's much easier and more user-friendly to use the signed PDFs. As this is not supported by the standard, we will demonstrate the third-party solution. Okay. There's another form for registering certificates. Certificates could also be stored in the database, but it's more secure and we prefer them from the Key Vault. Okay, we have added this certificate. Then we will go and specify in the setup that for the sales invoices, we will actually sign the outgoing PDFs. We will use the certificate that we have just registered. We will also use one signature appearance, but we will explain it later, and just provide some reason for it. Okay. Now if we go to the invoice journal and reprint this invoice using print management, we will get an email, because that's how we define the print destination settings in the print management. And this email will contain a signed PDF. So we have received an email. Let's open it. And here's the signed PDF. Our signed invoice. Okay, let's open the signature panel. He said that the signature is valid. We can also take a look at the certificate with which the invoice has been signed. That's our employee's certificate. That's the certificate of the certificate agency that has issued his certificate, and on the top, the certificate of the Trusted Root certificate agency. And if this root certificate would not be on an Adobe trusted list, then the signature would not be trusted by default. The receiver could add it manually, but it doesn't make real sense if you're sending massive invoices. The other thing here in the PDF is also the visual representation of a signature. So it's like a stamp or a seal that contains some basic data about the signer, reason and date, and also the handwritten signature. So it somehow works in pair by pair with digital signature that somehow grants the identity of a sender, grant that the document has not been modified on the way. What have we learned? Your secrets are more secure and better managed in a Key Vault. The use cases that we have seen could also be implemented without the Key Vault with secrets in the database, but that would pose a higher security risk. F&O supports integration with Azure Key Vault, but that is used just in some places across the standard application. So there is a lot of place for higher adoption in standard and in custom modules. And if you were using Windows Certificate Store or similar legacy store on your on-premise environments, Azure Key Vault is a good cloud alternative. Thank you for watching. I hope I've inspired you how to manage your secrets. I hope you've enjoyed it and found something useful. I would like to thank DynamicsCon for giving us a chance to share our knowledge and the voters who supported this session. Now it's time for Q&A and discussion. Please post your questions in the conference chat. After the session, you can find me on social media or reach me on Teams or email.
Hi, everybody. So, Micha, I don't know for the rest of the audience, but I thought that this session was just 5 minutes. It was so interesting, so I couldn't get enough of it. But before we start with the Q&A, what's with the T-shirt? So what's the D inside? You look like a Superman or something like that.
Oh, thank you. Thank you. Yeah, it's a superhero T-shirt, a Super D T-shirt, where D actually stands for DynamicsCon, but also for Docentric. So you can stop at our booth, and we have a few more T-shirts, and the first one can get one. So
great. So don't wait, everyone. Just go to our booth, as Micha mentioned, and post your name, so we will send you the T-shirt. Okay, so let's go to the Q&A. So, Micha, what about the backups of certificates and keys and secrets? Could you tell a little bit more about that?
Yeah, sure. Yeah, so when we're talking about security, backup is also super important. So yeah, we can back up all the secrets, certificate and keys in the Key Vault, and we can also restore them back. And we can actually back up even the non-exportable keys and certificates, but we can restore them back only on another Key Vault in the same subscription, so in the same Azure subscription. So it's all regularly and secure. So it shouldn't pose an additional security risk. So yeah, you can download you can download the backup of any object just from Azure portal, or if you do it regular, you can write a script, and that's more convenient for that. Yeah. So of course we have to back up, and we have to also restore them sometimes.
Great. So how does signing in cloud with Azure Key Vault affect performance? So is it similar to the local signature, or is there any difference?
Actually, it is a some kind of a REST web API web service call, and but at the end, if we are signing a document, maybe the signature itself takes 1 second, but the generation of a document takes much longer. So it doesn't really significantly impact the total time of document generation. So.
Okay. During the presentation, you mentioned the hardware security model. So what's that? Why do we actually need it?
Yeah, a hardware security model is a special device where the key is locked and it shouldn't be exported except in some special cases that are very, very well regulated. And we all know that kind of hardware security models. It can be smart cards or USB tokens or stuff, that kind of issues. But if we are talking about the Azure and the cloud world, there are hardware security modules stored in the secure data centers, and some can be shared, some can be there just for you. So.
Okay, great. And how much will it cost me if I use Azure Key Vault?
Okay, it depends, like anything in Azure. So I've done a lot of different testing for my demo and all that, and I think I've spent altogether 80 cents or something like that, less than $1. So the pricing is per transaction. The pricing is also per key. And so if you have a hardware security model, it's more expensive. If you have a actually hardware security model just for you, it's even more expensive. So the normal usage is really cheap. But if you want something exclusive, I mean, if you have a very big scale, then of course it can cost something. So, but then you have to check the prices.
Okay. So can we also use it for on-premise finance and operations?
Actually, it's not really related to cloud or on-premise, but of course, if you have an on-premise environment, it should be opened so that it should have access to the internet and to the Azure. So it depends on the firewall setting on the on-premise environment, but otherwise there is no limitation. So.
Okay, so nice to finally get a question. So Jake, thank you. So Jake asked, I don't know anything about electronic signatures. Is this key something I'd keep with me and would represent me, or is it more of a machine-specific thing?
Both. Actually, electronic signature can represent a physical person, can represent a company, or even some other entity. And yes, technically it's all the same. But if we're talking about a trust and how the certificate, how the trusted certificate should be issued, there are some differences. So if you want to sign it with your personal certificate, then you have to prove your physical identity. If you have a digital certificate approving your web domain, then you have to prove that you're an owner of a domain. If you want to sign in the name of a company, then you have to prove that you have that you're a legal representative of a company when so at the time of the when the certificate is issued. But after, when you have a certificate, the technology is just the same. So
great. So what was one of the biggest challenges you had when you were testing Azure Key Vault? What was the thing that you were struggling the most with it when you were discovering how Azure Key Vault works?
Actually, I was quite. I didn't have such any really bigger problems, but yeah, there were some minor ones. One of the quite tedious one is that when you're making a backup of your secret, when you're deleting the secret, and I wanted just to restore it back, and of course, the deleted secret were still in the recycle bin, so between the deleted objects, and I wasn't able to restore them back because the restored object would have the same name like the deleted ones. So so it wasn't possible. So that's one of these little details that you have to take care. Yes, when you're playing, and if you leave the default settings are that whatever you delete, it's just put in the deleted objects and is there for the 90 days, and you cannot delete them manually. So I mean, I think it's very positive. It's for the production setup, but maybe for the demo, it's sometimes not what you want. So
okay,
great. But otherwise, the Azure Key Vault works really well. So you just have to take care to properly secure the access credentials, and that's pretty much it.
Great. Yeah. So I would imagine that such a superhero as you wouldn't have so much trouble setting up everything. So okay, great, Miha. Do you maybe have some, let's say, I would like to test something in D365FO, and I don't know how to create, let's say, a certificate or where to get it. You maybe have some kind of a tool that you would suggest to use it for, I don't know, development or testing purposes.
Yeah, sure. So there are many tools for creating certificates. You can also create a certificate inside Azure Key Vault, and we have demonstrated some of them. There are also other tools. One of those is also made by Clement. That's I have to make some advertisement. We also have a free tool for creating certificates with different properties on our website. That's very handy, and you can use it for development, testing, whatever you want. So at the end, every certificate has different properties. So these different tools have different options which properties you can specify and how to do that. But at the end, the certificate standard is just one. So it's not so important which tool you use.
Okay, thanks. So we got another two questions. So the first one is use cases for signed documents, mainly invoices. What drives this requirement, a specific country?
Actually, so digitally signed documents give some trust, and in some countries, it's even legal requirement. You have an option to digitally sign the email or to digitally sign the document. And if you digitally sign the document that is attached in the email, this document can later be stored in some document management system or whatever, and it is somehow it is signed as the document itself. So if the issuer wants to have a better, let's say, a higher trust or just a higher option to prove that this invoice was really properly invoiced by the issuing company, then the digital signature adds some level of this trust and reliability, also in the legal terms.
Great. So another related question to that. So companies have survived for decades without secure documents, encryption, keys, etc. So why is it necessary now? Like some kind of devil's advocate question.
Yeah. Actually, it usually comes from the other side. So when your customers will start asking you why your invoices are not signed, or that kind of situations, that then you will start to think maybe we should really sign a digital invoices. So and so if you want that your electronically sent documents would have equal legal effect like a paper documents, then digital signature is one of the ways to go.
Maybe if I add something, Micha, to your answer. So basically, it's not just the problem of let's say, legally bound documents. So basically, if you want to compare the electronic document to the paper one, so on the paper one, you actually sign with your handwritten signature. And the same can be achieved also with electronic signatures. But there's one difference. With electronic signature, you first of all can prove who actually signed that certificate, so that's one thing. The second thing, that you can always calculate if the document or the content of the document was changed. And this not just provides you legal compliance, but on the other hand, you will also have fraud protection. So basically, if you trust the sender, which sent you the signed document, then you'll always know that the invoice that you received, and when you will pay it, it will be paid to the correct person. So there's quite a lot of sides to electronic signature, not just the legal part, but also fraud protection. Okay, great.
Yeah, I can just illustrate. We actually had one case in our business that the emails was tampered and changed between us and our customer. So we did not receive the document just as it was. We did not receive the invoice just as it was when the customer has not received the invoice as we have sent them to them. So if we would use these digital signatures in these day-to-day business exchanges, then that would not be possible. So and if everybody would actually expect that the documents will be digitally signed, then it would be, those kind of attacks would be much harder.
Okay. There's another question for Damian. So he says that he understands the benefits, and he was just wondering why it wasn't used 10 years ago. So maybe because it was not possible 10 years ago. So what do you think about that, Micha?
Maybe I'm not the best one to answer this question, but I know that this e-business and electronic signature and certificate story is there for maybe 20 years, and it's slowly evolving. So and becoming more and more of a mainstream. So it looks that this transition just takes a long time. I don't know. Yeah. It's more a question of business culture and legal requirements. So
yeah, it's the same. I think it's the same as with paper money. So basically, we nowadays have credit cards. We even have bitcoins and so on. But quite a lot of people are still paying with cash. So yeah, at the end, it comes to basically to the one that needs to enforce this kind of let's say electronic business. And if the country accepts that, so the one thing that Micha mentioned in Italian, when you want to send a document to the tax authority, in that case, everybody will start to use electronic signatures. But if that is not a requirement from the country, then yeah, the usage won't be so big as it should be. And yeah, so basically, yeah, we need the government to enforce that. And basically, in the European Union countries, there are quite a lot of countries that already did that. So if you want to be compliant, so in that case, you actually need to also digitally sign documents, especially the ones that have some business impact. and if you want to store them later on electronically.
Okay, maybe I can add a few words on that. So 10 years ago, many websites were still on the HTTP protocol, and today it's really hard to find one with HTTP protocol. Almost all the sites are HTTPS protocol secured by encryption and proved the identity of the domain via digital certificate. So that was a kind of an evolution in these 10 years, and maybe in the next 10 years that we will also, maybe we could expect that kind of evolution in terms of signed electronic documents. Maybe we will see.
Yeah. Okay. So it seems that there's no superhero to put another question in the chat window. So okay, just another thing. So yeah, somebody said sounds somewhat similar to the PIN versus signature on the credit cards. So what do you think about that, Micha?
Okay, yeah, maybe I'm not sure if I understand the question right, but yeah, PIN is some kind of security, and for example, when you're sending a PDF in the email, it can be encrypted with some kind of password. It can be your text number or some other password, and that's maybe a kind of something similar to PIN. So digital signature is something similar to your handwritten signature with some extra capabilities that don't exist in the physical world. So I hope that answers your question.
Yeah, I think it's also something similar that USA is still using. So basically, if in European Union, actually checks are something that's not really common anymore, but in the USA it's still a common practice, and as Micha, as you said, it takes time to change the behavior of what kind of payment terms, how we do business, and the same goes with electronic signatures and signing electronic documents and so on. So yeah. Looks like we don't have any more questions. So, Micha, I think so we do you maybe it's again a good time that you mentioned about the T-shirts. So if not everybody was listening, so when will you give away those T-shirts? So what everyone needs to do?
Okay, so yeah, just visit our booth. And I think then you will find a link there or something like that. And then apply for T-shirts. We have some of them. So the first come, first serve. So yeah, thank you everyone for attending this session and for supporting me at voting. It was very interesting for me to prepare it, and I hope it was also interesting for you. So enjoy the rest of the conference, and thank you DynamicsCon for giving us a chance to share our knowledge. So bye-bye.